much, Andy. So our next speaker is Alexander Eiselmayer. He will be talking about Touchstone2, a great tool that I had the chance to use myself. And we have again a best paper award. That's 1% of Kite papers, might I remind. So let's give a round of applause for the co-authors, Alexander Eiselmayer, Chad Wacharamanotham, Michel Beaudouin-Lafon, and Wendy Mackay.
Good afternoon, everyone. Thank you for that kind introduction. Today I will present to you our project Touchstone2, an interactive environment for designing controlled experiments. Before we start, I would like to do a quick poll. Please raise your hands if you're conducting controlled experiments. Oh wow, that's like almost the whole room, more than I expected. That is good. And the following, I hope, will be interesting for you. I will show you an application in which you can design your controlled experiments, do statistical power analysis, thank you Andy, and compare trade-offs of different design alternatives. Before we look at how this works exactly, let's review how we design controlled experiments. Suppose we want to test a circular and a drop-down menu on a desktop, a tablet, and a phone. In total, that would leave us with 6 conditions that we should test. Next, we need to recruit our participants. Within participants' design, each of the participants receives all of the 6 conditions. This has the advantage of gathering more data during a longer experiment and capture participants' variation for each condition. However, it is crucial that the order of tries is counterbalanced correctly across participants to evenly distribute potential order effects. 2 important questions need an answer. First, in which order should we assign conditions to each participant? And second, how many participants should we recruit? Answering these questions is sometimes tricky. Let's start by having a look at the first question. Suppose we want to repeat a condition 10 times to be able to average the data in each condition and reduce noise. We also want to avoid fatigue effects by keeping the experiment time to a maximum of 30 minutes. To achieve this, you can now reduce the number of replications and risk having more noisy data. Or you can remove a level from your experiment and reduce your ability to test your research questions. Either way, your decisions lead to some trade-offs that you need to make. Now, let's have a look at the second question. How many participants do you need? How many participants should you recruit? We have to look at the statistical power, which is the probability of detecting an effect in an experiment when that effect actually exists in the population. Assuming everything else is the same, as you recruit more participants, the statistical power increases. Power ranges from 0 to the maximum 1, and let's have a look at the following power curve. Conventionally speaking, we would like to have a power that is at least 0.8. However, statistically power also depends on how strong your effect is. We heard effect size earlier. For example, if we speculate that the effect will be weaker, indicated here by the green line, we will need to recruit more participants to achieve the same amount of power. Now suppose we use a Latin square counterbalancing. We can use a multiple of 6 participants in this example. Now we can decide whether adding 6 more participants, which means spending more time and money, would worth the safeguard of covering a weaker effect. Before we started designing Touchstone2, we interviewed 10 researchers in 4 areas and found different challenges that people faced during experimental design. First, creating the counterbalancing itself is difficult, it's not trivial. Our participants spent many days working on the trial table with the spreadsheet. Second, using statistical power to plan the number of participants is considered. Interestingly enough, none of our HCI researchers mentioned it. Third, the duration of the experiment usually is a tight limit, especially for HCI as we're working with humans. As an example, we had one interviewee who was working with small children. Duration could not be longer than 5 minutes. Fourth, researchers needed to communicate their experimental designs to colleagues and their supervisor. And last, you want to compare trade-offs of different design alternatives. Existing software tools support these challenges at different capacity. Some of the tools are developed with industrial experiments in mind and do not consider duration in experiments for human participants. Other tools have specific focus on power analysis, both for planning the experiment and post-hoc analysis. Tools developed in the HCI community addresses concerns such as duration and communication. Touchstone used a step-by-step approach to input experimental design parameters for one design. And NextP used a question and answer structure for the same information to make it more accessible for non-expert users. Touchstone2 builds on the knowledge from these tools and enables researchers to interactively compare multiple designs and their trade-offs. Let's have a look at Touchstone2 now. Suppose we want to create an experiment to test our 3 devices, desktop, tablet, and phone. Each condition is represented as an interactive brick. Let's add them to our variable device. We also have a second variable, our menu type, which can be circle or drop down. And now we can add both of them into the experimental design. To distribute potential order effects, we can choose a counterbalancing strategy. The number of participants, as we discussed, needs to be a multiple of 6, so we choose to recruit 80. The app automatically generates the trial table below according to the design specified. For each table, or in each table, lists all the conditions that each participant has to do. For example, participant 1 will test 6 trials starting with phone and drop-down menu, and then continue with desktop and circular menu. We can visually inspect how the conditions are distributed by clicking on each row or each cell. Here we notice that the participants need to switch devices several times, and this could be inconvenient and lengthen the experiment. So let's redesign the experiment to minimize the number of device switching. To do this, we duplicate the current design and adjust its name, its color, and move menu type into its own experimental block. From the new trial table, each participant now needs to change devices only twice. Next, we would like to check how many participants we need, so we activate our power analysis panel. You can see that the statistical power chart from before, and for the selected design 2, we estimate a medium effect size. For design 1, we estimate a smaller effect size, and you can use the handle directly to select the number of participants that you would like to recruit. We also added this feature that you can input your measurements to calculate an effect size directly, which is still working. While we were developing Touchstone2, we discussed a wide variety of different experiment designs. It often takes us 5 minutes to explain to each other what the experiment is about and how the design should look like. Sometimes after half an hour, we just recognize that Chad and I were actually on a different page how the experimental design should look like. To aid this communication problem, we created a declarative language for specifying experimental designs. We called it Touchstone language, or TSL. And as an example, I will translate the block shown here into TSL. The 2 independent variables and their levels are written with a set notation. In this design, we cross the conditions within the same experiment block. And again, we use the X as our set crossing notation. Let's add the counterbalancing strategy and the number of replications. The counterbalancing strategy is a function of the independent variables the number of replications, and possibly other experimental designs block, which is not shown here. Let's recap how Touchstone2 can help you design experiments. Users can directly manipulate experimental designs and see changes immediately reflected in the trial table and in the power chart. It promotes statistical power by keeping it visible during the experimental design process with standard parameters. But also, you researchers have the opportunity to explore statistical power and see how different parameters might change, and you can make a more informed decision about the number of participants you would like to recruit. We added the duration at the bottom of each experimental design so that you can get a good estimate of how long your experiment will be. With TSL and the visual interface, you're able to more easily communicate your experimental design to other researchers. Finally, Touchstone2 provides a workspace that researchers can work with multiple experimental designs side by side and directly manipulate them and expect their trade-offs in the power analysis as well as in the trial table. Touchstone2 enables several directions for future work that we are excited about. We open source Touchstone2 and TSL for others to develop and use. We would like to see more expressive interaction techniques and visualization designs for experimental designs without having to go through the pain of figuring out combinatorics. That's what we had to do. For example, making a more specification of experimental design that could be an input for data simulation and generating code for statistical analysis that follows up. This will allow researchers to more easily navigate the garden of forking paths from experimental design step to the analysis. Finally, since researchers can explore more alternative of experimental designs interactively, it will be easier to capture the researchers' degrees of freedom or the decision that they make while designing experiments. These decisions, together with the rationale, can be included, for example, in a pre-registration or a registered report. Ultimately, we believe that Touchstone2 is a small step towards transparent and more open science. I hope that I got you excited about Touchstone2, and you can try it online, get the source code at touchstone2.org. I would be happy to take any questions and insightful comments.
Thank you very much, Alex. So we have time for questions now. Oh, there are no questions. So I have a question. Have you considered Andy's anchoring effects for
No, so far we have not considered it, but I think it's very interesting because with Touchstone we wanted to create this platform where we could actually include these type of, let's say, different research angles on like the research methods that you're using, because what we had in mind at the beginning was, let's say, more quantitative experiments, but now if you're looking at subjective data, we can try to include that directly into Touchstone, and if there is a good way to frame that, we would be happy to actually include this.
Thank you. Thanks.
Yes, hi, Brian Hall from University of Michigan. First of all, love this. This is really fantastic. And I wondered on power analysis. So power is related to the tests that are being used, if I'm sort of thinking correctly. And so I wondered how it is that you manage that. Are you assuming a certain statistical test or approach, and how you have considered that?
Yes, so one of the main goals of Touchstone2 was to be able to create within participants designs. So in our power analysis, we have focused on F-statistics and within factor designs.
Oh, makes sense. Thank you.
Mackay, University of Michigan. I'm really interested in the effect size portion of this. I think people aren't very good at reasoning about particularly standardized effect sizes, knowing what they mean. I mean, mostly we just use these Cohen's thresholds that were designed for people's heights and have essentially nothing to do with most of the data sets that we actually look at, like this small, medium, large thing. So I'm wondering how or if you've thought about like how you actually elicit those things in ways that people can understand, that are grounded in their domain knowledge about what things they're actually studying.
We did not think of that. That is a very good question, thank you. Our main goal was that we provide this tool for everyone to use right away. And the Cohen's default values, let's say, are really just default values that can get you going without you knowing a lot about power analysis. And we added this option of that you can provide your own measurements, input them into Touchstone2, and then we can actually calculate an effect size from your measurements directly.
Cool, thank you.
James Egan, Telecom Paritech. Thank you very much for this. I'm really looking forward to using Touchstone2. I was curious about one of the challenges in creating and designing an experiment is dealing with the hidden consequences and ordering effects and alternative data sets and all of that sort of stuff. This simplifies the sort of task of how do I do the mechanical operations, but do you have any support for giving some of the guidance to somebody who doesn't necessarily know what they're doing?
Maybe yes and no. Thank you for your question. We created Touchstone2, and it does have let's say this feature that you can export something. So you can actually export and share your experimental design directly. So if you're completely new and you're not really sure what you're doing, you don't have to start from scratch, which might be very challenging if you're new to experimental design. So you can actually start with previous work, related work that might have been published. So in that way, we hope that it would make it easier for non-expert users to kind of get going with Touchstone2.
Thank you very much.
René Geselches from Cornell again. What I really like about this is that it highlights the difference between the design stage and the analysis stage of any experimental study. I want to reinforce what two people in front of me said, which is that the intuition around effect sizes is something that's very hard. So I teach causal inference, and students really struggle with, well, what's the right effect size to use here? So something that would help by maybe providing examples of what a 0.2 or 0.3 looks like in different papers could really help with that. My question is about the analysis stage, which is informed by the design stage. So the choices that you make about how you design an experiment do have an influence on how you need to analyze the experiment later on. And I'm wondering how much you are already or are planning to support that, because many people don't realize that quite and are unsure how to do it correctly.
Thank you for your question. Yes, we are doing this as future work. We try to include the statistical analysis into the Touchstone2 platform, but at this point we really want to have it as at least Touchstone2 as the design platform, as its own platform, not to confuse things, because as you said, the analysis is informed by the experimental design. However, it is still two separate steps. That's why we have moved these two applications apart, so to say. Thank you.
Last question.
Okay, so I was wondering if you have thought about edge cases. I recently designed an experiment where I realized I needed 4,000 experimental conditions. So the solution to that is a fractional factorial mixed design. And that was a pain to set up. And so I'm wondering, is that something your tool can do? Is it that powerful, or is it how do you get to the really complicated stuff?
So I'm not sure whether it can do exactly what you needed, but Touchstone language, so we have actually created two parts during this project. We have created the user interface with the blocks that you can manipulate, and we created the Touchstone language. And the Touchstone language is, as of now, much more powerful than the user interface. So your experimental design or your trial table, you would be able to generate that with the Touchstone language, so you needed to write that up in TSL and then put it into the parser, but you cannot do that at the moment with the user interface.
Cool, thanks.
Thank you.
Thank you very much, Alex. So with that, we conclude this session. And next up is the conference reception on hall 4, where there are